Hi there and welcome back to another Papetti Math YouTube video tutorial where we are going to finish up lesson 4 on quadratic transformations right now with exercise number 4 that says, on the grid below, graph the parent function f of x equals x squared. So let's start off by doing that, and we're going to go to our calculator and we're going to put in our parent function of x squared, and I'm going to pull up my table of values to see what points I'm going to be graphing. So I'm going to scroll up to my negative values as well. And I see that, yes, I have negative 3, 9, negative 2, 4. So let's go to negative 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So there's our parabola, our parent function of a parabola. And that's going to be y equals x squared, or f of x equals x squared. Now in part A, we want to graph y equals x minus 5 squared on the same set of axes and see how that graph shifted from the parent function of f of x. So let's go back to y equals, and this time let's go down to y2. And we're going to put in x minus 5 inside parentheses. And then we're going to square that. And if we're subtracting inside parentheses, we should know that our vertex is going to shift 5 units right. But let's double check, and now let's look at our graph. And yes, it does shift 5 units right. So let's go to our table of values now. And our table of values, our first value that fits is going to be 2, 9. So we're going to graph 2, 9. So we'll go 2, 9, and then we have 3, 4, 3, 4, 4, 1, 5, 0, 6, 1, 7, 4, and that would mean 8, 9. And when we graph this parabola, we're going to see that, yes, look at that. Our parabola has in fact shifted 1, 2, 3, 4, 5 units to the right from the parent function of x squared. So subtracting 5 inside parentheses does in fact shift 5 units right. Now we want to graph x squared minus 10x plus 25 on the same set of axes, and we're going to explain why it happened. So let's go to our y equals. Let's take out this right here, and we're going to type in x squared minus 10x plus 25. And we're going to graph that now. It's going to look like something like, okay, that. And we're going to go to our table of values. And again, we're going to look at our table of values, the ones that fit. And we're going to see that we have 2, 9, 3, 4. 2, 9 is already graphed. 3, 4. Okay, that's graph 2. 4, 1. 4, 1 is there. 5, 0 is there. 6, 1 is also there. Okay, so it looks like this graph right here is the same as this graph right here. Can we explain why that happened? Why is this the same as that? And we should go back now to either chapter 7 or chapter 8. If we go back to chapter 7 showed you that x minus 5 squared was the same as x minus 5 times x minus 5. And if you multiplied that out, you would get x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25, which would combine to x squared minus 10x plus 25, which is the same as this equation right here. One leads to the other. But if you looked at this from a chapter 8 perspective where we learned factoring, we could start with x squared minus 10x plus 25, And notice that there are two numbers that multiply to 25, and those same two numbers add to negative 10. And you might think that those two numbers end up being, well, 5 times 5 will give you 25. But how can you get them to add to negative 10? Well, they both have to be negative. And if both factors are exactly the same, you can rewrite this as x minus 5 squared. So whether you're looking at this from a chapter 7 perspective on multiplying or a chapter 8 perspective on factoring, both will lead you to the same conclusion, that these are the same because they are equivalent expressions. This exercise really leads us into the great study of quadratics that we are about to truly embark on. And if this video was helpful, please give it a thumbs up. And you're now ready for our final lesson in this chapter before we get into the algebra of quadratics. Thank you for watching.